In next illustration, it is given a positive point charge capital Q is fixed at origin. A dipole with dipole moment P is placed along x-axis far away from the origin. That means at a large distance from the origin, dipole is placed and it is pointing along the positive x-axis. Find number 1, the kinetic energy of the dipole when it reaches at the distance d from the origin, and second part of the question, we need to calculate the force experienced by the charge capital Q at this moment. Okay, so let us make the rough diagram of the situation. This is the charge particle placed at the origin and it is fixed, and dipole is placed at a large distance, and the dipole moment vector is pointing the positive x direction. So this is at a large distance, and dipole moment vector, you can observe it is pointing in the positive x direction. Okay, we can observe here this dipole will attract toward the charge particle. We can verify it if we find the electric field because of the dipole at the position of the charge particle. That means this will be in the rightward direction. This is the positive charge. That means this charge particle will attract toward the dipole. That means electrostatic force, we know, always occur in pair, because this charge particle is getting attracted toward the dipole. That means this dipole will also be attracted toward the charge particle. That means when we release this charge dipole, it will start moving along the x-axis in the negative x direction. Okay, so let us release this dipole like this, and it has reached at this position at a distance d, and at this time velocity of this dipole, say it is v. This is at a distance small d. As we know, the mechanical energy will remain conserved. That means we can apply conservation of mechanical energy, that is the initial potential energy plus initial kinetic energy is equal to final potential energy and final kinetic energy. Okay, now at a large distance, if we observe, the potential energy should be 0, and initially we have held this dipole. That means it is not free to move initially. That means it is having the initial kinetic energy 0 and initial potential energy is also 0, and we need to calculate the final kinetic energy, and we can find the final potential energy of the dipole and charge particle system. And here we can write the potential energy of the system associated with this charge particle and dipole equal to minus P dot E. Okay, so let us write the potential energy of the system. P is the dipole moment and E is the electric field at the center of the dipole because of this charge particle. As we know, this charge particle is positive. That means the electric field vector because of this charge particle at the center of dipole should be in the rightward direction. So this is E vector. We can observe here the E vector and P vector both are parallel to each other. That means we can write this dot product as minus multiplication P multiplication magnitude of E because of this should be equal to 1 upon 4 pi epsilon naught capital Q divided by d square, and multiplication cos 0 because the angle between P and E vector equal to 0 degree. Now we can further rearrange. We can now write this U final equal to minus 1 upon 4 pi epsilon naught PQ divided by d square. This is the final potential energy. Now let us substitute the values. Initial potential energy equal to 0, initial kinetic energy 0, and in final potential energy we have calculated, and final kinetic energy we need to calculate. This is the final potential energy. So let us substitute. This is the value of K. K is the final kinetic energy, that is equal to 1 upon 4 pi epsilon naught PQ divided by d square. So we have calculated this part A. Let us move to calculate part B. Part B is the force experienced by a charge Q at this moment. Okay, we know the electric field because of this dipole at the position of the charged particle, because charged particle is placed at the axial position of the dipole and it is at a distance small d, and we know at the axial position of the dipole electric field vector is parallel to the dipole moment vector. That means electric field at this position will be in the rightward direction. Okay, and we know the magnitude of this electric field also. We have the formula, that is 1 upon 4 pi epsilon naught 2p divided by d cube. This is the formula for the electric field because of this dipole. Okay, that means this charged particle is under the electric field of this dipole, which is having this magnitude, and we know force experienced by the charged particle can be given as F equal to Q multiplication E, and Q is the charge and E is the electric field, which we have written this, right. So now we can write the force experienced by this charged particle equal to this one. We can further rearrange. This is equal to 1 upon 2 pi epsilon naught P capital Q divided by d cube. So this is the force experienced by this charged particle. It will be in the rightward direction. And if you ask the what is the force experienced by this dipole because of this charged particle, this will be in the leftward direction and it will have the same magnitude. Why? Because electrostatic force always occur in pair, magnitude equal and direction opposite. So this is the final result.
Dear aspirants, Cengage India has launched the new edition of our JEE Advanced Physics books. Please visit www.cengage.co.in to buy a copy. You can also buy the books from Amazon or Flipkart.